Okay, so you guys can see my screen, right? With the data analytics with SQL and Python course. If anybody cannot see the screen, please let me know right now.
Yes.
Okay, good. Thank you. All right. So this is the name of the course. So these are the in-demand jobs of today and tomorrow for the foreseeable future, at least for the rest of my life. But for even most of you people also will see these jobs: business analytics, business intelligence, big data, data analytics. So these are all different names. And the reason with so many names is that these are basically multidisciplinary field, meaning that you have information and those best practices, these things and the tools, they are coming from all different areas of knowledge. So that's why and it's very quickly evolving. So that's why you have all these different names. So when the business people is first started using this, they call it business analytics. When the they started more intelligence, more knowledge convert, they call it business intelligence. Then came the big data at the dawn of this century, 21st century, to year 2000. After that, we had the suddenly an explosion of data. So, and it was so overwhelming, they call it big data. Then now big data terminology actually is going away now. In the next few years, you probably will not even hear big data. Then data analytics. Data analytics is right now very hot terminology right now. So it's just like business analytics, but it not necessarily just business. You can have any kind of data, and then when you do this, and what analytics means, I will come to the next slide. So the purpose of this slide is just to tell you that when you will hear all these things, advanced analytics, predictive modeling, artificial intelligence, machine learning. So these are all tools which contribute to this business intelligence, business analytics, data analytics. So and then data mining is an old term, but that's why some terminology you will hear from data mining, meaning that it's just like I think who was that who works for the diamond industry. So they know when to in order to dig out the diamond, you have to dig a lot of earth, and from that earth or the dirt, you have to sift out the diamonds. So same thing with the data, that we have so much data and you have to mine the information or knowledge out of it. So that's why they call it data mining. And then the data science is the hottest terminology right now. So these are all different. So don't bog down into this one. Business analysis is basically a very fundamental, non-technical kind of thing, which is actually going away, to be honest with you. In the next 5 to 10 years, there will be very few business analysts job left. They will convert into analytics or machine learning or data science. So it's a good time to learn these technical things, because if you are planning to be there, and I believe most of you are very young, so you will still be in the industry for the next 10, 15, 20 years. In the next 10 years, for sure, you will not have any business analysts. Those jobs will go away. So non-technical kind of thing. Anyway, okay, so this is where the jobs are. Where are the jobs? The US companies, they started extensive investment in business infrastructure to fix the Y2K bug in the 1990s. There was this because what happened that when I started, and even before that, 1960s, and when I started in 1980s, 1960s, 70s, in 80s, the storage was very expensive. So we have to be careful about how we use the memory. The memory was very expensive. The first calculator where I learned the programming only has 1760 bytes of memory. 1760 byte, that is a 1.7 kilobyte. And now we are, even our game and even our cell phone, my cell phone has 16 gigabyte of RAM now. That's 16 billion. So from thousands we have come to billions. That's a million time increase in my career in less than 40 years. So what happened that because of the Y2K bugs, and the bug was there because we were short, and memory was very expensive, storage was very expensive. So we were trained to use only 2 years for the year, so that we can save 2 bytes for the century. And everybody thought in 1960s, 70s, and even 80s, when I was doing that, nobody thought, everybody thought that these system will be outdated, out of service by the year 2000. But suddenly in mid 90s, we realized that no, I mean, once you get something into business doesn't like to throw away things if they can still make use of it. So they were still using airlines, for example, they were still using the 1960s cyber system. And ERP system, they were still using those 70s ERP systems. So what happened because of that, there was a huge investment in the infrastructure to upgrade their hardware and software in the mid 90s. And that's where you see a lot of IT people came on those what do you call H1B visas, because they needed so much manpower to fix those bugs. And but this spending continued, and what happened that the dot com came and it busted, and then there was an influx to increase the productivity. So in increasing the productivity means to invest more in the hardware and software. So this upgraded infrastructure, and with the advancement in technology, because in technology, as you know, and if you don't know, is called Dr. Moore's law. That was the Intel Corporation founder in 1950s. Actually, in 19 late 40s, he he had the idea when the first integrated circuit came in 1948. He had the vision, and he saw it that this integrated circuits capacity will be doubling every 2 years. So this means that the first integrated circuit only has, let's say, four transistors. In 2 years, they will become eight. In another 2 years, they will become 16. So by the time I came on the scene in 1980s, mid 80s, they were almost close to a million. Not million, but yeah, 100,000 some transistors. So that's why we had the personal PCs, and that's where the IT really bloomed. And then now we have several billions of them. And that's why we have multiple cores. Each core has billions of transistors. So this is called Dr. Moore's law, that the capacity of transistors in an integrated circuit is doubling almost every 2 years, 18 to 24 months. So this thing, improved data collection. It made the cost lower, and then suddenly we had in the data deluge. So every aspect of business, from operations, manufacturing, supply chain management, customer behavior, everything now has to upgrade it. They have all these different devices, digital devices which are collecting data. And then storage became cheaper, so we are storing data. So what happened that this led to data deluge, or the big data phenomenon, and that's where we are. So now once we have so much data, companies are sitting on mines of data. What do? So they have this to develop the tools and techniques, and techniques come from mathematics and statistics, which is a branch of mathematics. So these tools and techniques, on the collection of data. Now there's a difference between data and information, and I will come to that, I think, in the next slide. So in the collection of information, how to organize, how to transform them, meaning that because these tools and techniques, they are very mathematical models. So those mathematical models are very rigid. They can only work on a specific kind of data. So you have to transform your data. The real life data is very dirty. It's very what we call unstructured. So you have to structure them, into a format that these tools and techniques which are coming from mathematics, they can use them and reformat them. Then we study or analyze them to find trends and relationships and reach to some conclusions. That's the data mining or data business analytics, business intelligence, that we can dig out, transform the information into knowledge, or so that we can use them for decision making. And then sometimes even predictions also. That's where data science comes into. So the purpose of these slides is to give you a big, bird's eye view of everything which is going on in IT right now. So that's why you may feel overwhelmed, but just listen, because you will be listening them more and more as you go in your career. So it's better to be aware of these terminologies and these things, what's happening. So the main purpose of data analysis is to understand the information on some deeper and more meaningful level than just the numbers. For example, in the accounting, they just care about the numbers. They play with the numbers, but this one is more than numbers. What these numbers mean, what these numbers represent, what we can use them. So that's why you see a lot of accounting and everything. All those jobs are also going away, because computers are good at numbers. They can crunch the numbers, no problem. They can, but getting information out of knowledge out of it is a new field. That how do you get the information out of those numbers? So this ubiquity of data and opportunities, that are so cheap and all industries. So what happened that in the old days, like even in 10 years ago, 20 years ago, companies hired statisticians, mathematicians, and mathematical modelers and analysts to explore data sets manually. And now with the spreadsheets like Excel, you will see Power BI and a lot of other tools, Python, for example, and programming languages. Now everybody can use them, and everybody is expected to use them. So that's why I'm saying that the pure business analyst jobs are going away, because everybody is expected to know how to use these technical tools to turn the information into knowledge. Okay, but there's another aspect. It's called the big data aspect. The volume, variety, and velocity of big data is overwhelming for the old systems. So that's why we need more sophisticated models and more sophisticated programming languages like R and Python. R is a statistical language, which are very common. I started my data science field with R, but now Python has taken over. In the next few years, probably it will be some other programming language. Python is not going to be there for another, forever. So, and then the declining cost of hardware and software, all these things basically are creating a lot of new jobs, new job description. But the common theme is how to organize and, how to study, organize, transform. And this is the common theme. And this is what, you need to learn in data analytics, basically. And the data is coming actually from, because a lot of your devices are interconnected, like in the through the internet or whatever. Then we have IoT, Internet of Things. So all our small devices, everything, your door lock, your switches, electronic switches, your light bulbs, everything is connected to the internet. So that's why they call it Internet of Things. They are generating data. This is called machine data. They are generating some data, they're collecting data, and they are sending it through the internet. And they're linked to the internet and send this data to somewhere, and a lot of devices are connected also. So that's why the skilled data analysts are some of the most sought after profession in the world right now, because the demand is so strong and the supply of these people who can truly understand this is so limited. And the reason is that because this technology is evolving very quickly, and it's a truly multidisciplinary. You need to know statistics. If you really want to be a data scientist, a real data analyst, who has an idea about data science, so you need to know mathematics, statistics, all those things. But now, because of these tools, even non-mathematicians also are supposed to know how to use those tools, even though you do not understand the underpinnings, the underpinning mathematics or statistical models behind them. But you need to be able to use them and be able to tell where to use which model and things like that. Okay, so that's why that data analysts command huge salaries and excellent perks, even at the entry levels. Okay, so what is again summary? What is this? The science of analyzing raw data. Raw data is data, meaning just this data which is collected. Is collected by accountants, is collected by your bookkeepers, is collected by devices. That's called machine data. So all this data, whether it's a financial data, it's a machine data, whatever kind of data, that those numbers are called data. Data is nothing but numbers. They don't they you I mean, if I tell you, for example, if I let's say I tell you 37, you would not know what 37 means. I mean, as you know, 37 is a number, it's an integer, but what does it mean? But when I say 37, for example, I mean my number of years of experience. So when I put a label to it, that number of years of my experience, 37, then it becomes information. That, yeah, this 37 in this context represents the year of experience, for example. So that's why data analytics is a very broad term, that encompasses many diverse types of data analysis. Okay, so we have very different kind of data analysis. You perform different data analysis on, for example, financial data, or your whether you're trying to do just simple accounting or you're trying to do management accounting. That's a different kind of analysis. Similarly, machine data, it requires a different type of analysis. So that's why any type of information can be subjected to data analytics techniques to get insight that can be used to improve your things. So data analytics techniques can reveal trends and metrics. Metrics is nothing but a collection of numbers. So to represent something, that's a table. Basically, really it's a number, and then you have some kind of a table to describe those numbers that would otherwise be lost in the mass of information or data collected. Now, this information can then be used to optimize your processes, business processes, to increase the overall efficiency of a business or a system. An important point is that data analytics focuses on coming to conclusion based on what the analyst already knows or suspects. So it's very important. That's why, even though non-technical people who have the business knowledge, that's why, as I was saying, that the best way to get a job is to start as a even unpaid or a volunteer internship. Because what happens that gives you the knowledge, the business aspects of the business. And when you have learned that in 3 months, 6 months, and then you apply them, these techniques, then the company cannot afford to lose you, because you have learned about their internal, which again take them 6 months to hire somebody and pay them that person. And then, and so that's a big investment for the company. So that's why the best way to get a job is just get into a company, any opportunity, as an internship or as a volunteer even. And then once you show your skills, you understand their business, then you will become invaluable for them. Then they value you and then they will hire you. So there are four different major types of data analytics. Okay, so you have to understand, first of all, the basic is descriptive. Descriptive means that just what happened. So this is like just accounting numbers, or some other in the accounting financial data, or it could be some other thing, like metrics, that okay, this is what happened, and this is a number. They just give you the views of the past, that this has happened, and these are the numbers. Okay, our sales are stronger this month or last month. Our cash flow is good this month, or is it declining? Things like that. The next level up is a diagnostic analytics, which focuses more on why something happened. So you are trying to look for the reasons. So relationships. This involves more diverse data inputs and a bit of hypothesizing. Now, hypothesizing is a statistical term, that be based on your data. You hypothesize, you make an hypothesis, and then you make a test to test your hypothesis to accept it or reject it. Okay, so that involves some statistics, but now we have tools even in Excel that you just have to understand the concept, and then you can use those tools to do the diagnosis, because they are very powerful tools. For example, did the weather affect the beer sales, or whatever sales you are looking at? Did the latest marketing campaign impact your sales or not? So you need to know those diagnoses, based on some analytic techniques. The next level up, these are the hierarchical levels. The next level up is the predictive analytics, that once you have diagnosed, at least you have identified some relationship, and then the next level is that what is likely to happen in the future? Can you predict? And the businesses, will pay you whatever you ask if you can really make a good predictive model, because that way they can plan for it, and and then they can really improve their bottom line. And the highest level is the prescriptive, a course of action, not only just predict the future trend, but also the like, for example, the likelihood of a hot summer is measured as an average of these five matter is above 58%, then we should add an evening shift to the refinery and rent an additional tank to increase output. So this way, you can have you can have the results of these predictive analytics combined to give you prescriptions, so what to do, business actions. And that's why they're saying that in the next 5 to 10 years, you will see these robo advisors on the board of big companies. They are already on the high tech companies on the advisors. They have these robo advisors, and then these will become more and more common. Then actually they're predicting that you will have these automated system, robot system, on the board of directors of the major companies in the future, in the very near future, actually, in our lifetime. Because they can analyze this all this data, and then they can come up very quickly with this prescriptions. Okay, so what do the data analysts do? They take the mountains of data, and then they mine into it, dig into it, to spot the trends, make forecasts, extract information, so that they to help their employers make better informed business decisions, right? And then every one of you of us actually will have a different path, because different companies are at different level. What kind of data they're collecting, how much, what is their system, and things like that. So that's why, and this field is evolving very quickly, so that's why everybody's path will be different. Okay, so in general, data analysts are everywhere. That's why there are so many of them are needed in healthcare industry, financial institution, big tech, all these companies. Everybody needs data analysts. Okay, so as our society become more increasingly digital, the amount of data being created and collected is growing. It's actually growing exponentially. Analyzing this ever-growing data with traditional tools is a challenge. So that's why the actual value of organization data is found when questions can be answered and used to create competitive advantages. And that's done through the prescriptive analytics or predictive and prescriptive. Okay. So yeah, there are a lot of jobs. Last time I searched, there were more than about 100 million jobs for data analysts. So starting from you can search it and you can quickly find it. So that's why it's easy to get into this field. Anybody can get into from. You can come from any field because you can apply this into into any field. And that's why the ImpactTek, we are designed this course so that anybody can come, even the housewives who never worked before, they can also quickly learn it in 3 to 6 months and then start working on that. Okay, so this course data index is very highly hands-on. I In the next 2 weeks we will do about 85 exercises on Excel. And then after that, we'll on the Power BI we'll have another 50 exercises. Then I have put 1 week for SQL and then 3 weeks for Python practices also. So you will have a lot of hands-on. Okay, any questions? Sorry, I'm talking too much for last 15 minutes. Any questions? If you have any question, please speak up because sometimes the team's screen is not, so I cannot see your hand. Yeah, go ahead, Sakina.
I have a question. So, we have given the AWS login to do the labs over there. So, is this included in that, or is this something else beside that?
No, that is something different. I mean, because AWS data analytics is purely big data on AWS
Mhm.
platform. So, do
Mhm.
you have any idea of AWS before or no?
No.
No, okay. So the reason is that I've been teaching this course with ImpactTek for since 2020. So last 3 4 batches, we did it on AWS. But what we found out is that people, they do not have AWS experience, so they have a hard time. So that's why this course which I'm starting today is redesigned to do with the Excel. And before we had AWS platform and then Python and SQL, of course. But instead of AWS platform, now we are starting with the SQL so that everybody can take advantage of it. Now, if you are interested in the AWS part, then you have to know some foundations first of the cloud and AWS. Then but these same tools you can apply there also, so that's not a problem. Okay, Mohammed Ubaid, you have your hands up. You have a question?
Yeah, actually, is there any way that a little bit so in the future just to slow down when you start uh, what you're talking about? So this is general information at the beginning is okay, but for the next time, if that's possible, a little bit to slow down.
Oh, sure, no problem. Yeah, because
Thank
I
you.
get excited.
Yeah,
So
I know. Thank you.
yeah, yeah, because that's no problem. Thank you for pointing it out. Yeah, yeah. Please keep me checked. So because I tend to speak too fast, because I have a lot of information in my head. My head is churning at 1,000 miles an hour. So so I have to, unconsciously start talking very fast. Okay, thank you. Anyway, so to answer your question, Sakina, yes, for AWS, yeah, I'm not planning to go on AWS, but I will give you maybe if we have time in last weeks, I will definitely show you the AWS because you have been given the AWS access also. So you will have an idea that how to do these data analytics on AWS.
Right. That was my question because I think we have to do the labs over there as well, and
If
then
you,
do your assignment as well, right?
no, I will not give you the assignment on that AWS. No, because I'm not teaching. Because once I did that, what I did first 3 weeks, um, I spend on look over here. So in the first week, I'm doing it on using Excel, right? Excel and Power BI. Let me show you. Let me show you that what I used to do before. Hold on a second. Just to give you an idea that before in the last two couple of years, I've done this course 3 4 times at least. So we used to do this. Oh, this is the same thing. Sorry, right? Yeah. So this is what you're talking about. So what we used to do the overview of AWS cloud services, and then we do the lab over there. So these are the labs on the cloud foundations. So this is a separate course. This is called practitioner's course. They have 6 labs. Now these labs are not, I'm not planning to cover in this course because this course is completely redesigned, especially this one, So, and then after doing that we used to go into Python, and then we go into data analytics, which you are given the access to just to have an idea. Over there are again 8 labs. So I used to cover those 8 labs there, but those are very advanced labs in the sense that they are tools also. So definitely, I can give you an overview of those tools. If you guys, let's say, for example, decided we don't want to learn Python in that much detail, let's do it on AWS. So I can do that because we have access to AWS. I am an AWS accredited educator, so I have access to AWS course, and I think I give you the access to those courses, to the environment. So, but this time I'm not planning on doing the AWS. I'm planning on doing this on smaller level so that everybody, the people who do not have the cloud experience, they can also learn through Excel. Okay, does it make sense?
Yes, 100%. But I guess we would have to take the AWS practitioner exam, right?
No, you don't have to take the exam. No, you don't have to take the exam, but you have to take that course to learn AWS practitioner or foundation. That's about 3 weeks course. If you take that course, just learn about AWS basic foundations, then you can do that data analytics on AWS platform.
Okay.
All right.
All right.
Yeah, that's why I told you. That's why these are so many things.
Right. It gets confusing.
Yeah, it gets confusing because there are so many different things are coming in together. Over here, that's why you have all these big data, and so when you're talking about AWS, now all of these things you can do on AWS, but AWS is much more capable than Excel, because Excel is just whatever you can hold into your memory. It can only have 1 million rows. It can only have 16,384 columns. That's the limit of an Excel sheet. 1,048,576 rows and 16,384 columns. That's 16 megabyte of 16 data. But in the AWS, there's no limit. You can have billions of rows of data. And in real life, we do have billions of rows of data. So for that one, Excel will not be any useful. So I will explain the difference, that why we need cloud, or why do we need big data, or especially AWS. Okay, as we go along. So you will have a better idea. But yeah, please bear with me, because there are a lot of different things coming together. It's a very hot field, and it's a very new field. I mean, new field in the sense that a lot of things are they are coming together. Okay. Oops. All right. So this is my plan for this time, that there's 2 weeks on Excel, so that anybody you can learn some Excel techniques and Excel, how to do the analysis on Excel. Then move on to Power BI, where you can do some more. Power BI is like there you can have a lot more analysis if you combine it with their with the Microsoft Azure, for example, their cloud. But we do it on AWS, so we can do it on AWS also, and then they have their own tools. So once you understand the concepts, you can learn the new tool in a few hours. Learning a new tool is not a big deal once you understand the underlying concepts. Okay. All right. So the new job opportunities are for what we are going to what we call DDD, data-driven decision making. All industries, they automate this data. They are trying to automate the data-driven decision making, and for that one, we have traditionally we have databases. So those databases, they are called OLTP, Online Transaction Processing System. They just process the transactions. Now for transactions, you don't need that much data. You only need one screen, two screen, a few screens, of data. That is nothing. Excuse me. So you take that OLTP. Where's my cursor? You take that OLTP data, and then you apply these data engineering, data processing, or data collection, including big data technologies. So either on AWS or whatever, on Oracle or whatever you are, And then we convert into data warehouses, which is the OLAP, online analytical processing. So for online analytical processing, you need to take your transaction processing data and you have to convert it into so that you can apply the data science, data mining, or data analytics techniques. They do not work on the transaction processing systems. And the reason I will talk about as we go along. So those that's why we have to transform that data and reformat, rechange, or restructure them so that our models can work on that data. And then once we have this, we make a pipeline. So it's automated process, and then so we can ultimately our purpose is to have the dashboards and our automated data driven decision making automated. So we don't need human managers. I'm just kidding. But yeah, ultimately we will not need so many business decision makers in the future. Only one or two human beings will be enough. The rest will be done by machines. We don't need so many management people. I mean, believe it or not, but they are also going away. So, all right. So there is a kaleidoscope of terminology again. Business analytics. So that's it's just because there are so many different technologies coming together. It's a confluence of a lot of different technologies, a lot of different disciplines. It's a truly multidisciplinary field now, especially the machine learning and artificial intelligence. Okay, the data science basically. All right. Okay. So solution definition. So analysis again, repeat. So that I mean, repetition is good because one time you may miss it. Once you know more knowledge, more information, then you can you see it again, and then you can make better understanding. You understand better. Okay, so this is again another definition that analysis is a detailed examination of something in order to understand its nature or determine its essential features. This is what we call abstraction. In computer programming, in a data in an IT field, we call it abstraction, meaning that we examine our problem, we examine the data, its nature, and then we identify or synthesize only the essential features. That's called data abstraction, or just abstraction in object-oriented programming. So you will hear here another term very common in programming. Once we go into Python, you will hear it more often. But I'm just giving you a heads up that there are so many different terminologies because they are coming from different disciplines. So this data analysis is the process of compiling, processing, and analyzing the data, raw data or information, so that you can use it to make decisions. And that's just another definition is that analytics is the systematic analysis of data. So you have data, you analyze it systematically using some techniques, some models, mathematical models, then you call it analytics. So the data analytics is the specific analytical process applied on just data, because analytics can be applied on a lot of other things also. Okay, but now data analytics has taken over everything else. All right, so this is all just different definitions. There are some examples of that. What are some benefits of data analytics? Right now, organizations are spending millions upon millions of dollars on data storage. The problem isn't finding or generating, collecting, or storing the data. The problem is that to do what to do with the data, and that's why they are willing to pay you big bucks if you can help them with this. So, for example, the companies are using for customer personalization. Like you go to Amazon or any website, online vendor, they personalize. So that is coming through analytics. They call it business analytics. Fraud detection is another field, that they sometimes you hear, for example, your transaction is declined, or why? Because their automated system, this machine learning system, it thought that it's a fraud, so it will decline your credit card. Then they give you a call, and then you have to confirm with that before they can approve it. Security is a big field for data analytics. So you can apply, if you learn this data analytics here and you are more technical minded, and if, let's say, for example, somebody is mentioned that they have a security plus, like Alida Thomas has a security plus certification. So what she can do, she can apply this through data analytics techniques to security, cybersecurity. And there are tools like Splunk, for example. So they expect you to know data analytics and and security concepts. So you can apply it to that field. User behaviors, psychologist, all these behavior analysts, you can apply it to your, how to influence people and this kind of things. Financial modeling and forecasting is one of the earliest application of data, of course. what trends can be detected in the terabytes of data. Tera is a trillion. Mega is a million, kilo is 1,000, mega is a million, giga is a billion, and tera is a trillion. And now we are going into peta. Peta is actually quadrillion. 1,000 tera is a peta. So very soon you will have. In AWS we have petabyte scale data, which is not possible, of course, in Excel. Real-time alerting, so these kind of things. So that's why all these things are coming together. So what is the big data? Originally, big data was any collection of data that was too large and complex that it becomes difficult to process using traditional data processing application. Meaning that whatever the organization has the capabilities, if the data is overwhelming for that capacity, it cannot be done within that capacity. We used to call it big data. But now capacities have become almost unlimited because of the cloud. So that's why this big data term is going away. Even AWS has renamed its certification for big data certification. They used to have a specialty certification called big data analytics. And now they have changed its name and split it into two different certifications: data analytics, one of them, and the machine learning, another one. So this big data term is going away, but it's been there for about 20 years, plus 20 years. So that's why it will take a little while to go away completely. But you have to understand the features of big data. That big data have huge volume. Petabytes, terabytes, very common. Terabyte is common, petabyte is coming. Large variety, different kinds of data. Not just your Excel sheet. Not that's a structured data. Not your just databases. Those are structured data. You have a lot of different kind of data, audio, videos, your text messages, all those things. And data is coming at a very high speed, high velocity. So these are called these five V's: variability of data and intense complexity. Okay. So this is the business, the challenge that the organizations are having right now, that they are growing rapidly. The volume, and the speed of data coming in are only two factors, which you need to consider. For example, 800 terabyte. So of data and need near real-time insights. So I need a data analytics solution quick. Okay, so these are called the 5 V's of big data. Okay, so I'm not going to spend much time on this one. So, but you have to understand this one. So what are the components of a data analytics solution? So, because the analytics perform in each of these components, each of these stages, it is also called a pipeline, or stages require different services and different approaches. So your data analytics solution should include at least the following components. Number one is that your raw data, machine data, or your financial data, whatever data, whatever the numbers are coming in, you have to ingest, you have to take them in, store them, collect them, and then properly store them. Maybe change them in the format, convert them into some structure. Then so that you can do the analyses, you can analyze the data. And then you can visualize and consume the data so that you can get some answers to your solutions or problems, and then you can get some insights. So you have to understand it, that this is the purpose of any data analytics solution, whether it's on Excel or it's on AWS, or doesn't matter. You have to have a system to collect, take the inputs, collect the data. You have to store it properly. During from collection to storage, sometimes you do the transformations. These are called data transformation. Then you have to do further transformations, apply some mathematical models to process and analyze them. And then you can visualize them through graphs, because a picture is worth 1,000 words. And then, you can get some answers and things like that. Okay, so I've been talking too much. I think it's time to take a break. Let's take a quick 6-minute break. We come back at 11:15 because I have a lot of things to cover. I think I might be slow today, because we are only doing a 2 hours courses instead of 3 hours. We used to do 3 hours, but we learned that people cannot take 3 hours, it's too much. So that's why we decided to make it 2-hour courses instead of 3 hours. So let's continue on, because we have a lot of material to cover, but don't worry. Usually, even if I have to go over, I do some extra sessions so that we can have the material covered. So don't worry about it. In the beginning is always slow. All right. So what in the cloud, or what they call big data pipeline or same thing. Collecting the data, processing, analyzing it, visualizing it, and then and because you collect the data, you store it, and then this is a loop because it processes and analyzes that is data from the storage. So that's where you need the data warehouse or data lake. These are on the cloud, and then you visualize it. This is what you can do on your computer, on your laptop. Visualization tools on Excel, on Power BI. So those tools, Power BI, Excel, they are only helping you here for collecting, storing, and sometime even processing and analyzing. You need some other solution, especially if the data is huge. So this is in a nutshell. Okay, so there are many big data tools. So this is about data science, which you can ignore right now. Data science is a yeah. This is another good slide that because data science is a truly multidisciplinary thing. So there are some on the x-axis you can see that experimental and theoretical disciplines, and over here descriptive and predictive analytics. So data analytics is in the top level of prescriptive and the between experimental and theoretical. Okay, all these analytics. On the experimental side is a lot of your research, your data science, all those things. And then machine learning is all coming from theoretical basis, but also goes towards prescriptive and even predictive, and methods and algorithms. So these are all theoretical, but they are the underpinnings. But you don't have to know details about them unless you want to go into pure data science. Okay, you will be playing somewhere here, meaning that you have to know, you will be using the technologies which are proven, which are not experimental, not purely theoretical. They are practical. They have been proven, and they have been shown to be practical. And then but you will be going more from descriptive. You will be going towards diagnostic, and then predictive, and up to prescriptive. Once you get into prescriptive, then that's where the decision making happens. All right, so this is a very good slide to spend a couple of minutes on, because this shows you the whole infrastructure. Oops, sorry. Okay, so what is analytics? So you have the data at the lowest level. This red part is your hardware, basically your storage. So you store structured data are like your databases. Where you have well-defined columns, and then attributes of the data. So that's where databases come into. But right now with the big data, your data might be semi-structured, like we will be seeing in our example also. XML and JSON is very common, graphs and series. And then you have totally unstructured data like text, images, audios, and videos. They have no well-defined structure. So these are the three categories, broad categories of data, which we collect and store in somewhere. We store them either in data warehouse, but these days the data warehouse terminology is also going away, and we call them data lakes. The difference is that in data warehouse, the data still has to be structured and organized. But in data lake is just like a lake that different streams come and put. It's a reservoir. So that's why the data lake is a term, especially in cloud. Then we have these powerful software tools like relation database systems, Hadoop, indexing, NoSQL, files. All these are the data infrastructure we create on top of data lake. Then once we have this data infrastructure, these are the jobs of data engineers. These are very technical jobs, and data engineers usually do that. Once they have done their job, then your job as a data analyst, or it comes into play. And then there are two broad categories over here. Both of them apply machine learning or artificial intelligence algorithms, which are based on mathematical models and statistical models. Either you can do business intelligence, which most of I assume that most of you will be doing business intelligence. So for that you need online analytical processing on the left, excuse me, which we will be learning, reporting and dashboards, and discovering data, analyzing data. This is also called EDA, exploratory data analysis. Exploratory data analysis. In data science, we call them EDA, but in general, we call them data discovery or data mining. Okay, so that's where probably most likely in this gray area you will guys will be working on. More technical, advanced analytics require all these predictive, descriptive, and optimization, simulation, and all these techniques, which you most likely you guys will not be doing, but you can do for this one. You definitely need the Python. You cannot do it in some. You can do some optimization and simulation in Excel, but for most of them you need more powerful programming languages. Once you have these advanced analytics, this is all comes under analytics. So you guys most likely will be in this left area, gray, with the gray boxes, these boxes. Okay, but this is the big picture, and that's why the confusion is. And a lot of jobs, and but these jobs will also be shifting toward the right. So in the next 5-10 years, if you want to be competitive in the field, you will have to ultimately learn some programming and some of these techniques. Otherwise, you will be out of job in 5-10 years. Right now, it's okay. All right, so this is a data science process. As you can see, we formulate a question, we extract data to which we think that can answer or help us answer our question. Then we do EDA, which I was referring to, exploratory data analysis. We find some relationships, we find some inherent relationship in our data. Then we do the formal modeling, and then we interpret the results and make a decisions. Okay, and these are all usually very loopy. So as you can see, this tells you that during each stage of a life cycle of a data science, there are loops within loops. So this is lot of data analysis. Now this is actually old standard, but it's very pertinent. It's called CRISP-DM, Cross Industry Standard Process for Data Mining. Data mining is an old terminology. Okay, so you will not hear it that much, but if you go in the old 10, 20, 30 years, before it was all data mining. Now it's all data analytics. So you have your data store, which could be right now is a data lake. It could be data warehouse. It could be databases. But right now, these days, is most likely data lake. Then you have, you have to have your business understanding, and you have to understand your data. That's where you need some, non-technical business analyst kind of people who understand their business. They also call SMEs, subject matter experts, SMEs. Okay, or domain knowledge. So you have to have the domain knowledge of your business, so that you can take the data, understand the data, and then you prepare data, which we will be doing in Excel also. But you also need some programming for that, scripting at least. Then you build your models, and then you go back and forth until you evaluate your models until you're satisfied with the output of your model. Then you deploy it in production, and then you have to keep updating your model. So that's why it's a cycle. So this is the overall process, which I just want you to at least understand at a high level, because this is very important. If you don't understand at a high level, in the interview, or you will have very hard time even performing, because you have to understand that why, who needs my data, what kind of data they need, who do I go to understand what they need, and things like that. So you always go to SMEs or business analyst for understanding your the business problem, and then you decide and you talk to data specialists, data engineers to get you the data. And then once you get the data, then you have to do some preparation, and then start building the models, which you will do in our course. So there are these 7 stages, but that's okay. You don't have to worry about it. Those 7 stages. All right. Any questions?
Will you be sending these slides to us?
Uh, these are slides are the actually, because they are for more than this course. So I don't know. Yeah, I will extract some of them. Yeah, definitely. Whatever I covered, I will send them. Yes.
Okay.
Yeah,
Thank
but
you.
not all of them, because they are the work of hundreds of hours, and from different books, tens of books, and many years over. So they kind of that's why there are so much information there.
Okay. And then the data mining that you went over, the SME, doesn't that go with like the whole old waterfall process with how
No,
businesses
the
used to
old
work?
waterfall process doesn't work with this.
That's
That's
what
why
I'm
these.
saying. So that's why it's data is also obsolete with the data mining as well.
Yes, exactly.
Okay.
So that's why they have this CRISP model, which is more agile.
Yes, the
That's why
steps.
they have going back and forth loops, right? Yeah, the
Yeah.
waterfall model. So the people who do not understand the waterfall model, that's the old, model for software development. That you have first, you collect the requirements, which takes about, I have worked in the project which takes like 2 years in just collecting the requirements.
Mm-hmm.
And by the time you have collected the requirement, defined them, what they call elicitation. Once you have the requirement elicited and documented, then you then you go into design. First you do the high level design, then you do detailed design, then you do the programming, then you do the testing. That's called waterfall model. That model nowadays nobody uses it because it's outdated now and it's very inefficient. I have worked on project. We spent $2 billion in a project, $2 billion, 2 years, almost more than 2 years, and just collecting a requirement, and then we scrap the project. So those $2 billion down the drain. So that's that. Those models don't work. So that's why we learned that this agile is that you just take your important requirements, you document the requirement as you go along, but you only start working on, and then you make 2 weeks to 3 weeks long what they call sprints, and then on those you deliver something. And then you get the feedback from your business users, business analysts, and then you improve upon it. So that's the model is more applicable in data analytics and data mining. All right. Okay, so everybody has Microsoft Excel. Anybody doesn't have Microsoft Excel? Let me ask this way. Okay,
Doesn't
if you,
or does, Brother Anwar?
I'm sorry,
You said does not or does?
who does not have it?
Oh,
You have it, right?
yes, I do.
Oh, good. Okay.
Um,
Okay.
I don't have it. I have something similar to it. Does
LibreOffice.
that matter? Or huh?
LibreOffice.
Yes.
Okay. Yeah, that's fine.
Okay.
But you might have something different because LibreOffice. Because I will be very specific to Excel. So it's better if you just. I mean, you can actually get free Excel also. You believe it or not. Just Google. Let me show you. Um, yeah, let me show you because having an office will be very important. So just Google, you know, how to get Microsoft Office for free. Okay, and then and you can go to office.com, sign up for the free version. You can sign up for the free version on the Office 360, and then you just have to have a Microsoft create a Microsoft account. Okay, and then you can use it for free. So I recommend that please get it because otherwise today may be fine, but as we advance, go into advanced things, you might be lost.
Okay. Thank you.
All right. Okay, so hold on a second. Let me send you some data file which you will have to open in in your Microsoft Excel to follow along with me because now we are starting the hands-on part, right? So let me send it to you. Okay. So I'm sending this Excel file, which you can open and then follow along with me to work on Excel. Okay. So when you open it, it will look like this. Okay. Hold on, give me a second.
Are you emailing us?
Yes, I did. Check your email. It may go to your spam folder because
All
it's
right. And how about the study materials? Where can we get that? Yeah.
I'm sorry, what? The slides?
Yes.
Yeah, I'll have to send you the slides.
Email, right?
Yes, I will email you later on.
Okay. All right. Thank you.